Okay, in this video we're gonna look at a few more examples of the vertical asymptote and the whole, the point of discontinuity. Let's just kind of review when the denominator of the polynomial, the rational function, when the denominator equals 0, you have point of discontinuity. When the denominator is 0, you have point of discontinuity. There are two types of point of discontinuity. If that factor remains, it doesn't cancel out, then we have vertical asymptote at that point, at the x value. If, however, that specific factor cancels out, it disappears from the denominator, then we have a whole. So that's just kind of a rule. So let's look at example 1. What are the domain and point of discontinuity of each rational function? So you have to find the domain and point of discontinuity. There can be more than one point, so they say points of discontinuity. If there is a point of discontinuity, are the points of discontinuity whole or asymptote, vertical asymptote? So we have to decide. Let's look at the first example. X plus 3 is on the top, x squared minus 4x plus 3 is in the bottom. So in order to figure out if this factor, any factor can be cancelled out, we have to factor this quadratic. Any quadratic form we have to factor. So if I try to do that, 2 numbers multiply to 3 and add up to 4 will be negative 3 and negative 1. So it will be x minus 1 times x minus 3 in the bottom, and I have x plus 3. Okay, so these bottom numbers tells us that we have points of discontinuity at x is equal to 1 and another point at x is equal to 3. So we have 2 points of discontinuity. Okay, so the domain naturally, so that's one answer for the point of discontinuity. Domain would be all real numbers except x is 1, x is 3. So x can be any number other than 1 and 3. That's the domain. And then we have to figure out if these point of discontinuities are whole or vertical asymptote. So if you look at this factor, is there anything that I can cancel? Well, there's none that I can cancel. That means this denominator will just remain as they are. That means we'll have vertical asymptote. So it will be both vertical asymptote. So we have figured out all the information. Let's look at the second example. Okay, you look at the bottom first to look for the points of discontinuity. So if this bottom number is equal to 0, then at that x value we have point of discontinuity. Can x squared plus 1, that's the bottom number, can it be 0 at any value? Well, we try to figure that out, so we minus both sides, and then we have x squared is equal to negative 1. Now we square root both sides with plus and minus. Cancel square and square root. X is equal to plus and minus square root of negative 1, which is plus and minus I, the imaginary number. So in the real number system, there is no such number that if you plug into x, you will get x squared plus 1 equals 0. There is no such number. Which kind of makes sense, because if you plug in any number, like even if it was negative 5, then if you square it, you're gonna get positive number. Or if you plug in 0 and square it, you're gonna get 0. And if you add 1, it's never gonna equal 0. Right? So that's why there's no point of discontinuity. Why? Because point of discontinuity only happens when the denominator equals 0. In this case, the denominator can never equal 0 unless x is imaginary, which we are excluding. So what are the domains? Because there's no point of discontinuity, then domain will be just whole real number. X can be any number. So because we don't have any point of discontinuity, we don't have to figure out if they are whole or vertical asymptote. So we are done. Let's look at C. Okay, let's look at the bottom number. When this equals 0, then we have point of discontinuity. If x minus 4 is equal to 0, add 4, x must be equal to 4. That means at x is equal to 4, we have a point of discontinuity. One point of discontinuity. That makes our domain equal all real number except x is not 4, because if x was 4, then it will end up with a 0 denominator, which is not possible. So we figured out point of discontinuity and domain. So is that point of discontinuity a whole or vertical asymptote? To figure that out, we have to see if that vector cancels out or it remains. If it remains, it's going to be vertical asymptote. If it cancels out, it's going to be a whole. So to figure that out, we have to factor this quadratic. So this will equal to 4x minus 4 x plus 1. The top becomes this and the bottom is x minus 4. So seems like we have common factor, and then we can just cancel this out. I will have x plus 2, x plus 1. Because we cancel this factor out, that means we have a whole. So that point of discontinuity is a whole. Okay, just kind of confirm that. Let's graph these functions. Look at their their shape to confirm that we are correct. So first one is x plus 3 divided by x squared minus 4x plus 3. This one we did not have any point of discontinuity, and actually we had point of discontinuity at 1 and 3. So let's look at this shape. So it looks like we have a vertical asymptote at both points. So if you look here, the graph shoots up, but x can never be 1. X is still like 0.94. X can never be 1, and then we have this vertical asymptote, meaning we have this line that the graph reaches to but never touches. And we have another vertical asymptote at 3, because if you look at the x value, x can never be 3. It's gonna be 3 point something all the time. So that our conclusion seems right. Let's type in our second graph. According to our conclusion, we should not have any point of discontinuity. Okay. Although this graph looks a little weird, there's no point of no whole or no vertical asymptote. So that kind of confirms our conclusion. Let's look at the last one. Oh, I typed it wrong. It's 3x. Okay. That just looks like a line, because according to our conclusion, we cancel out the factor of x minus 4. We just have x plus 1 graph, which is true because we have y-intercept of 1 and the slope of 1. Let's look at our whole, which is at x is equal to 4. Let's zoom up a little bit. If I click this point 4, then it says, well, when x is 4, y is undefined. That's why this is a whole, not the vertical asymptote, and this function is discontinuous at x equals to 4 with the whole.